if you want to see that or actual efficiency results for that DC-DC step-up converter, you are in the wrong video. What will follow after this intro is just a whole lot of boring measurements. So for the real mailbag and review of that step-up converter, card link. Please ignore the clutter on that side of the breadboard. So here's my step-up converter. I'm feeding it at the moment 0 volts. Okay, so here full scale 4 volts, here full scale 400 milliamps. That's the output voltage, and now we can turn up. So if I give that 1 volt of input, I actually get some output. So interesting. 2 volts, I still get some output. Okay. You saw that? So whatever that chip is, that's interesting. Whatever that chip is, it's not the one from the datasheet. I'm at 1.9 volts. And I go to actually 2 volts, a little over. And obviously the step-up converter switches on. That's very interesting. And there's a little hysteresis. So there's a protection circuit here. So once I am at 2.1 volt, I can go down to 2 volts. It's still working. If I go down to 1.9, yeah, it switches off again. So it seems to work at 2 volts. Interesting. So yeah, obviously not the chip from the datasheet, the same circuit, but other specifications. Nice. Yeah, let's put some load on it and see what happens. So I adjusted the whole thing for 7 volts or about, and yeah, 7 volts is incidentally the voltage, minimum voltage of an input, power input pin of an Arduino. And yeah, the 2 volts are the discharge voltage of 2 AA cells. And now we try to put 10 milliamps on that thing, little load, and okay, that didn't work. It switched off. So okay, 2.1 volts, and put a little load on the thing. And yeah, it's working. So yeah, the 2 volts are really a fantasy value. And you can also see I'm drawing here about 40 milliamps. So yeah, maybe I will write the numbers down so we get yeah, an efficiency curve for the whole thing. But nice to note, 10 milliamps load on the output, yeah, doesn't do much on the voltage. That's nice. So I'm gunning now for 20 milliamps. And the whole thing broke down again. So 2.2 volts. I need to write that down. Sorry. So aiming for 50 milliamps. And it breaks down again. So we go to 2.3 volts. Yeah, 49 milliamps. Close enough. But yeah, I don't know. Next stop, 100 milliamps. And yeah, does not work, does it? Okay. Yeah, it's the resistor cannot take the 100 milliamps or 700 milliwatts. So let's try it with 2.4 volts. Still breaking down. 2.5 volts. Still breaking down. 2.6 volts. Okay, that was me. Okay, getting hot. So 100 milliamps, yeah, 103, who cares? And I'm drawing 230 milliamps. Let's go for 200 milliamps. And of course, yeah, voltage is breaking down, so we go up and up and up. And now something interesting is happening. I'm increasing the voltage. I mean, I see it's increasing here, but the amperage is not increasing at the same time. And now we're in a stable operation at about, well, 3.7 volts, and we're drawing about, switch to the lower scale, yeah, let's call it 3.8 volts, huh? And we are at the lower scale at about, yeah, 450 milliamps. Let's try something less taxing, like 150 milliamps. Oh, I think we can go back to the other scale, 400 milliamps, full scale, and I can turn down to, you see, I can turn down to 3 volts. Okay. And that, yeah. But 3 volts is the absolute minimum. And I don't know if you heard that. I mean, you hear it when the thing is working out of its spec. Let me try to give you the sound. Don't know if that worked. Anyway, so yeah, roughly 150 milliamps at 3 volts. And yeah, again, 450 milliamps input current. So I will stay at 3 volts now, input voltage, and go down with the amps, 100 milliamps, 50 and so on. And we are at about 100 milliamps. And we are drawing, yeah, this is back to 400 milliamps full scale, about 290. At about 50, we are drawing 130. And at 20 milliamps output current, we are drawing about, well, yeah, let's say 55 milliamps. And finally, at 10 milliamps output, yeah, 30-ish. Now, the 3 volts are equivalent to about 3 almost empty AA batteries, and I will turn that up now to 4.5 volts, which are 3 full AA batteries. So 4.5 volt, and you can see the input current is of course going down, and for 10 milliamps we are drawing now, yeah, I have to guess here a little bit, let's say 18. For 20 milliamps we need, yeah, 35. For 50, yeah, almost 90. For 100, about, yeah, 180. And for 150, about, yeah, 250. And please note the output voltage is quite stable, yeah, independent of the load, even if I have no load here. Yeah, that doesn't change much. And neither the diode nor the inductor nor the chip get really warm. Oh, that's a good thing. Now I turned down the input voltage to 4 volts, which would be 4 AA batteries, almost empty. We are still at, yeah, about-ish 150 milliamps, and we're drawing about 280 milliamps at the input. At 100, we need 200 milliamps input. At 50, about-ish, yeah, let's say 95. Now, let's say 100. At 20, we still need, yeah, 40. And at 10, yeah, a wee bit, oh, let's say 20 milliamps. So at 4 volts, we have no problem supplying 200 milliamps. But yeah, we are drawing, ooh, lower scale here, 400 milliamps. Ooh. I turned up the voltage here, other scale, 25 at full, to 6 volts. That's 4 AA batteries full. And at 10 milliamps, we're drawing about, yeah, 50 milliamps input. At 20 milliamps, we need about 30-ish. At 50, we need 65 milliamps. At 100 milliamps, 135. And at 150, about 190. And at 6 volts input voltage, we have, of course, no problem to drawing 200 milliamps, and we need to provide 260. Now, if we change the output voltage to directly 5 volts to run an Arduino and not use the power input pin at 7 volts, but supply directly the 5 volt rail, which you could do at 10 milliamps and 3 volt input voltage. So again, 3 AA's almost empty. We draw about 20 milliamps. At about 20 milliamps, we need, yeah, 45. At 50 milliamps, yeah, 100. At 100 milliamps, yeah, 195-ish. And at 150 milliamps, about 295. And that's it for 3 volts. If I try to get 200 milliamps out, doesn't work. I have to increase the voltage and the current, and it's, yeah, it's Mm, yeah, not really. Uh, maybe. Uh, I wouldn't recommend it, but at yeah, a little under 200 milliamps, uh, we're operating at 500, 600, 750 milliamps input current. Now let's try the whole thing with 4.5 volts input voltage, so 3 full AA cells. And there 200 milliamps shouldn't be a problem. Yeah, 250 milliamps input current, yeah, about-ish, 200 out. And for 150 milliamps, I need about 190. For 100, 125. For 50, we need, yeah, a little bit over, yeah, let's say 65. For 20, yeah, 30. And for 10, yeah, 15. Now, if you really endured the whole video of the measurements, kudos to you and thank you. I just put that out, yeah, I don't know why. Because I had the material. Anyway, you should watch the video I mentioned at the beginning with the real mailbag and the real review. Okay? See you there. Bye.